Very good afternoon to everyone. Today we are going to have course introduction on fluid mechanics. So in this the course module, we are going to see the basic fluid properties and its different characteristics and few typical practical examples. Discuss. Now we'll move on to the module number 1, introduction to fluid mechanics. So, fluid mechanics is one of the most trivial and important subject in mechanical engineering. So mostly here in this subject, we are going to study the liquid characteristics subject to statics and dynamics. Say, for example, you take water, gas, other medium. When it is subject to force, what are the mechanical behavior of the fluid characteristics? That we are going to discuss in this course on fluid mechanics. So in short, I can say that fluid mechanics is a branch of science which describes the mechanical behavior of the fluid. To understand, let us take a simple example, mechanical behavior of the fluid. So we can able to classify the fluid direction as two types. One is the laminar flow, other one is turbulent. These two types of flow narrates the movement of the fluid from source to destination. To take laminar flow, here the fluid will flow in a definite path without any deviation. So it moves like a straight line path direction, laminar flow. Okay. Whereas a turbulent flow, the fluid flow should be irregular, non-uniform in nature. It will flow in zigzag different directions. To take an example of turbulent flow, water falls from the mountain, from the hills. So it will flow like a turbulent. So the water will be sprinkled randomly from the top of the mountain in uncontrollable manner. Whereas laminar flow, the flow of fluid will be restricted and it will move within the safe velocity in a regular pattern. So these are the graphical illustrations which describes path of fluid flow. Another definition given here, fluid dynamics. Fluid mechanics can be always called as dynamics of fluid, so which analyze and test the movement of various liquids and gases which is seen inside the closed medium. Say you can take a glass beaker, suppose some water in the glass beaker, and I want to measure the pressure of the water just by keeping the capillary tube in the gas beaker. So what is the pressure raise, pressure fall in the capillary tube? So that can be quantified with the help of the capillary tube parameters. Now let us move to the real world application of fluid dynamics. So what are the areas that the fluid dynamics is being covered? Say for an example, design and manufacturing of hydraulic system, take pump and turbine. Okay, so hydraulic turbine, water turbine. So it runs on the primary source of water that is the primary fluid based on which discharges power, same like submersible pump. So both the device works on the medium of water. So there we can able to test the viscosity, kinematic viscosity of the water, even the flow velocity of discharge, and finally, based on which we can able to calculate the performance efficiency of the hydraulic devices. The next one, fluid behavioral characteristics inside the heat exchanger is boiler, then refrigeration and air conditioning system, the use of refrigerant fluids in air conditioning system, refrigeration and air conditioning system, and even aircrafts and ships. Okay. So these are the areas where we can able to feel the importance of fluid dynamics in air system. So before moving to the properties of the basic fluid, here in this slide, I just want to add on one more important thing. So there is a software called the computational fluid dynamics. So that is mainly used to simulate and analyze the fluid flow motion that can be either turbulent or lambda. Okay, by just constructing a 3D simulated uh, real system like turbine, pump, even aircraft and exhaust unit. So by constructing a 3D model of that, you can able to simulate, study the characteristics of the entire thing. So in mechanical engineering, computational fluid dynamics is one of the big core area where more number of engineers are wanted in this field. Now coming to the basic physical fluid properties, so we will see one by one. First thing, the basic primary thing to be noted here, density. So how will you measure the density of the fluid? You know what is the mass of the fluid and volume of the fluid. By taking the ratio between these two quantities, we can able to empirically quantify the density of the fluid. So let us take here the glass beaker is filled with some quantity of water inside the glass beaker. So here, what is the weight of the water? That is the mass, and how much the volume of the fluid occupied inside the jar or beaker. So based on which we can able to arrive out what is the density of the fluid. So the unit for density is kg per meter cube. Next one is viscosity. So viscosity, which measures the amount of resistance offered by the fluid due to shear stress. Say for example, you take a water pipeline. When a water is moving inside the pipeline, so it creates an internal resistance due to the friction between the fluid layer and the inner chamber of the pipe. So due to the friction, some internal resistance is being offered, okay, to control the motion of the fluid with a given applied stress acting on the top and adjacent layer of the. Viscosity is nothing but we can able to find out what is the amount of the internal resistance offered by the fluid when it is subject to dynamic or static mode. The unit for viscosity is Newton second per meter square. The next property is the temperature. So how to measure the temperature of the fluid? So using clinical bulk thermometer, we can able to study the temperature characteristics of the fluid. Say for example, a hot boiler heat exchanger can able to measure what is the degree level of hotness of the body, help of the temperature reading. The next one is the pressure. The next property, fluid pressure. So this can be calculated by using the following equation. Pressure of the fluid is equal to applied force by area. So let us take the graphical illustration which is represented here. Say the external force which is acting on the top layer of the water surface and the area occupied by the fluid inside the container, cloud container. So force by area. So based on which we can find out what is the internal pressure maintained by the fluid inside the container. The next we are going to see about the specific volume. So this is the next property of fluid gas. Specific volume can be defined as a ratio between the volume of the material and the mass of the material. Specific volume is more or less mostly proportional to the density. We know the density of the mass by volume. If you take inverse, that will become specific volume. So here comes the SI unit standards for specific volume. So meter cube to kilogram. When you're solving the problems, you can use this kind of unit measurement standards for getting the answer. And specific weight, next property, specific weight. So this is the ratio between the weight per unit volume of the fluid. So the SI unit is given as Newton per meter cube. Specific weight of the fluid interchange with respect to the temperature of the fluid. So it is one of the influencing parameters for measuring the specific weight of the fluid. When you take specific weight, acceleration due to gravity, density, so both will be important information to be considered when you are calculating the specific weight of the fluid medium. The next is the surface tension, next property. So the surface tension mainly occurs due to the external the, the force which is influenced on the over the fluid surface. So as a result, due to surface tension, so the fluid area may get shrunk due to the intermolecular attraction between the liquid molecules. The next one is the specific gravity. It is one of the dimensionless quantity which does not have any specific gravity of the fluid. So it is defined as the specific weight of the given fluid to the standard weight of the fluid. Here the standard weight of the fluid we can take as density of water, standard weight of the fluid. So vapor pressure is the next fluid property to be discussed here. So vapor pressure is nothing but the equilibrium pressure above the liquid state. So the vapor pressure of the fluid that vary according to the temperature. If the temperature slightly increases, it may also be high. If it is low, vapor pressure will be low. The next concept is cavitation. What do you mean by cavitation? How it occurs? So the cavitation is nothing but origin of forming bubbles or air voids within the fluid. So this phenomenon takes place due to the relative misalignment of the pressure drop in the fluid, so that the cavitation takes place due to the variation of the pressure drop. So if the fluid pressure is below the vapor pressure, then cavitation takes place. There arises the air bubbles inside the fluid. And what are the various different types of the fluid? We are going to see one after the other. Ideally, is considered to be incompressible, which does not have any viscosity. But practically, there is no ideal fluid in any case. It is just an assumption. Ideal fluid is considered to be incompressible. But when you take real fluid, which has some amount of viscosity, and that may vary according to the thickness of the fluid medium. So you take the viscosity of water, which is far less compared to the viscosity of the kerosene, depending upon the relative layer of the fluid. Newtonian fluid. Here, in this type of fluid property, shear stress is directly proportional to the rate of shear strain, whereas in non-Newtonian fluid is not directly equal to the rate of shear strain. Ideal plastic fluid, here the shear stress will be more than the yield point, but is equal to the rate of shear strain. So these are the standard types of fluid given as per the existing definition. Now we will see what is surface tension. Surface tension is nothing but the external tensile force which influences over the top layer of the fluid medium. So due to the tensile force, the area occupied by the fluid inside the closed system, so that may show some variation in the pressure limit. So it is just an external force acting on the surface of the fluid. What is capillarity action? So this is defined as the phenomenon of rise or fall of the liquid surface due to gravitational attraction of the fluid. Let's take an example here. Beaker, small capillary tube, is used to measure the rise and fall that gives the reading of pressure here. And next, we are going to see about the different types of pressure. The first one is absolute pressure. So this type of pressure can be measured with reference to the vacuum pressure. Say, for example, if I want to find out what is the absolute pressure for the thermometer, say I want to measure 30 degrees Celsius. That is my basic temperature value, 30 degrees plus environmental impact on the instrument while taking the temperature measurement. Say 30 degree plus 5 or 10 degree due to the variation in the environmental room condition. So based on which say 40 or 45 degrees Celsius, I can able to take absolute pressure value. Gauge pressure. The pressure that can be monitored with the help of the measuring techniques. The Bellotti Boron tube apparatus. These instruments are used to find out the gauge pressure. Vacuum pressure that is far less below the atmospheric pressure limit. So zero, there is no pressure. Vacuum is empty. There is no pressure being made inside the chamber or any closed fluid. Only minimal pressure is there. So with this, I end my presentation about the basics of fluid mechanics, various properties of fluid characteristics. So we will meet in the next presentation session. Thank you once again.